All right, today we're going to talk about something that sounds, super technical, but is actually a secret superpower for your everyday life. It's called algorithmic thinking. And no, this isn't just for coders. It's really a way to solve problems, any problem, more clearly and way more efficiently. To get started, let's just bust a common myth right off the bat.
So let me ask you this. Do you have to be a programmer to be a really sharp, efficient problem solver? Because there's this idea out there that structured, logical thinking is some special skill reserved only for people who write code all day.
Well, the answer is a huge no. Honestly, the truth is, you're already doing this stuff. You're using the basics of algorithmic thinking every single day. You just might not realize it. So today, we're going to show you how to spot it, how to get better at it, and how to turn it into a tool you can pull out for pretty much any challenge life throws at you. To really get a handle on it, we've got to start with the foundation. See, algorithmic thinking is really built on just 4 core ideas, 4 pillars. Think of them like building blocks. Once you get these 4 down, everything else just kind of clicks into place. First up is a fancy word, decomposition. All this means is taking a huge, overwhelming problem, like planning an entire family vacation or tackling a giant report for work, and just breaking it down. You chop it up into a bunch of smaller, way less scary to-do items. It's the first step to making any complex problem feel manageable. Okay, next we've got pattern recognition. And our brains are already wired for this. We're natural pattern-finding machines. This is all about looking at a new problem and thinking, where have I seen something like this before? It's about not reinventing the wheel every single time. Why start from scratch when a solution you've used in the past might work here too? The third pillar is abstraction. Now this one is a really big deal. It's the skill of just filtering out all the noise, all the junk details that don't matter, so you can focus only on the information that's actually relevant. It's about seeing the big picture instead of getting bogged down in tiny, unimportant details.
And finally, we have algorithm design. This is where it all comes together. It's the grand finale. You take those small pieces from decomposition, you use your pattern recognition, and you build a clear, step-by-step recipe. That recipe is your algorithm, a set of instructions so clear that pretty much anyone could follow them and get to the right solution.
Now, all that theory is great, but let's be real. The only way to get better at anything is to actually practice it. And here's the best part. You can start doing this right now, today, in your normal life. No coding required, I promise.
So, let's try a fun little challenge. I want you to write down the exact steps for how you make your morning coffee. And I mean exact, not just make coffee. I mean every single little action. Pick up the mug, walk to the sink, turn on the cold water. Then, when you're done, hand that list of instructions to a friend or family member.
And here's the test. Watch them. If they hesitate, get confused, or have to ask you a single question, boom, your algorithm has bugs. The goal is to write instructions that are so perfectly clear, so unambiguous, that there is zero chance for misinterpretation.
Need another one? Okay, think about the grocery store. Most of us, we just wander the aisles, right? We grab things as we remember them. But what if you treated it like a game, an optimization game? What if before you even walked in, you planned out the absolute most efficient route to get everything on your list?
And just look at the difference here. On the left, that's the chaotic path, zigzagging all over the place because you forgot the milk and have to go all the way back. But on the right, that's the optimized algorithmic path, a clean, efficient route that saves you time and, let's be honest, a lot of frustration.
Okay, so you've started debugging your daily routines. Awesome. But if you want to really level up your training and sharpen that logical muscle, there are a few more structured exercises you can try. Let's try writing something called pseudocode. Now, don't let the name scare you off. It's not actual code. It's basically just a way of writing out your thoughts in plain English, but in a very structured, logical way. Think of it as a blueprint for a decision, like, say, choosing what to wear in the morning.
See, this forces you to clearly define your rules. You're just using simple if-then statements. If the temperature is above 25 degrees, then I'll wear a t-shirt. Else if the temperature is below 15 degrees, then I'll wear a sweater. What this little exercise does is take the messy, automatic process that happens in your head and makes it crystal clear and explicit.
Now, if you're more of a visual thinker, flowcharts are an incredible tool. Seriously, they let you map out an entire process, showing all the different decision points and the paths you can take. A perfect classic example is troubleshooting something we've all dealt with, a broken Wi-Fi connection. So you start at the beginning. Check the lights on the router. That leads to a decision. Are the lights blinking? If the answer is no, the chart points you to the next logical step: restart the router. If yes, it points you somewhere else. It's a visual algorithm that walks you right from the problem to the solution, with zero guesswork involved.
All right, now for the final and maybe the most important mental shift of them all. To truly master algorithmic thinking, you have to adopt the what-if mindset. This just means you're always thinking ahead, anticipating what could go wrong. Programmers call these edge cases.
Just look at the difference here. Normal thinking is just a simple plan. I'm going to drive to work. That's it. But algorithmic thinking is a robust plan, full of backup plans. If I get a flat tire, then I'll call a cab. If the main road is closed, then I'll take the alternate route. You're not just hoping for the best, you're building a resilient, problem-proof plan.
So if this has sparked your curiosity and you kind of want to dive a little deeper, there are some really great resources out there. A book like Grokking Algorithms is amazing because it uses cartoons to make these ideas super easy to understand. And websites like Brilliant.org have interactive puzzles that really help build your logic skills.
And here's the most important thing I want you to take away. Thinking this way is not about being robotic or less creative. It's the exact opposite. It's about getting the simple, repeatable stuff out of the way so efficiently that you free up your brain power for the really hard, creative human problems. It's all about being prepared, efficient, and clear-headed.
So, I'll leave you with a final challenge. Just think about it. What is one simple daily routine in your life, making tea, packing a lunch, anything, that you could turn into a perfect bug-free algorithm this week? Give it a shot. Thanks for tuning in.